Hey, Chris here from LlamAcademy, here to help you, yes you, make your game dev dreams become a reality. In this video, we're going to do something totally different than we've normally been doing. I always have been assuming that if you're watching one of these videos, you kind of already understand how to write some code, but that leaves out a lot of you who maybe are copy-pasting to get some result and don't really understand what's happening underneath with all that code that we're writing in each tutorial. What that means is this is part one of a new series where I'm going to focus on very basic introduction to coding type of things that you need to know to get started writing your first scripts and get into your programming journey in Unity using C#. In this one, we're going to write a really basic script that we've kind of done something really similar actually in my very first video. But what we're going to do in this one is slow it down, explain step by step, what does this do? Why do we need this? How does this work? And where can you go to get help when you don't understand something? That's the number one thing I want you to take away from this video is how to help yourself when you don't know what's happening. Both Unity and Microsoft give really good in-depth explanations of how to do almost anything, not everything, but a lot of stuff using C# and Unity. Sometimes Microsoft's documentation can be really technical if you get into like the language specification and if you don't have the coding background, which I assume if you're watching this video in the series, you're not going to have that. And that's okay. You don't need to understand the full depths of what defines a programming language and how does it work in the compiler level. That, for the most part, doesn't matter when you're writing code. Microsoft does have some pretty good tutorials and pretty good documentation when you're wanting to know a specific thing or how something works. In the description, I'm going to have a bunch of links to all the stuff that we're going to look at and all the references that you're going to need to understand in depth everything that we're talking about in this video. I'll also be bringing up, while we're talking about each topic, some documentation explaining how do I know that we want to use N2 for a number format. If you've never written any code before, this video is totally safe for you to get started, and this is the one I think you should be watching first if you have never written code, because we're going to really just break it down like you were writing your very first script. Even if you don't know what a script is, that's okay. We're going to talk about it in this video, and by the end of this, I'm going to assign you some homework so that way you can further your understanding on what we've talked about so far. I've got to give a huge shout out to my Patreon supporters. Every single one of you helps the channel grow, reach more people, and add value to more people. And that means more people are making their game development dreams become a reality. If you want to become a supporter, you can go to patreon.com/LlamAcademy, get your name up here on the screen, and get a voice shout out starting at the silver tier. And speaking of those silver tier supporters, I have Raphael, Andrew Bowen, Gerald Anderson, and Autumn K. I am so grateful for all of your support. Thank you. To get started, let's make sure that we have all of the right tools installed. First, we'll open up the Unity Hub. As of very recently, Unity Hub 3.0.0 is the default one that you'll get whenever you install the Unity Hub. We're going to go to Installs on the left side and then click Install Editor, and we're going to choose the latest LTS release. Currently, that's 2020.3.26 F1. We want to use the LTS release because this is the most up-to-date, stable release that Unity has. The other ones that are available are in the tech stream. These contain some features that are not fully production ready or are more experimental. When we're just getting started, we want everything to be stable. We don't want to run into some weird bugs. So that's why I would always recommend starting with the LTS release unless you have a really good reason to use the tech stream. So I'll click that and we're going to make sure that Visual Studio is going to be installed. I don't want to get too much into the how to set up a Unity project. I just wanted to really highlight that we do need Visual Studio to be installed, and this is how you can do it using the Unity Hub. I'll then quickly create a new project based on the 3D template. For the scope of this tutorial, which one you choose doesn't really matter. You can even use an existing project that you already have. In our scene, I have a TextMeshProUGui component on a canvas, a background image that is the entire size of the canvas, and what we're going to do is make something happen over time. That's basically what scripting does, is we want to take some values and modify them over some time or whenever an event happens, like a user click, contact with physics, whenever AI has achieved a goal, something like that. For what we're going to do, we're going to just count up with this text over time. To start writing code, what we have to do is create what's called a script. In Unity, we use the C# programming language to write these scripts. And all this does is provide us a way to manipulate something that's happening with our game objects, our TextMesh Pro, our canvas, whatever it is that we want to modify. So we'll right click in the project panel, go to Create C# Script. Whenever we're giving a script a name, we want it to be descriptive for what it's going to do. That way later, whenever we have a lot of these in our complex game, it's very evident from just the name what the purpose of that script is. For this, since we want it to count up some TextMesh Pro text, I'm going to call it count up. Then if we double click on that, it should automatically open our Visual Studio. If it doesn't, we can go to Edit, Preferences. We'll get a window that has preferences and click on External Tools. For the external script editor, we can click on Visual Studio 2019. When we open up Visual Studio and get our count up script open, there's some code already here that Unity gives us by default. At the top, we have some using statements that give us access to other code that Unity gives us by default, and also the system.collections and the system.collections.generic. You'll see those two are kind of grayed out. It's because they're not being used so far. The Unity engine one, though, is. That's why it's the full kind of white text. Since these are just giving us access to other code, and we are using the Unity engine, and we know in this script we want to use TextMesh Pro, right? We're going to update some TextMesh Pro text over time. So what we'll do is say we're going to use TextMesh Pro. That's using TM Pro. That will then give us access to stuff like the TextMesh Pro component that we get in the Unity inspector that maybe you're already familiar with. If we move down a little bit, we have a public class count up. That's the name of the script that we just did, and a little colon mono behavior. This line will almost never change for you. What Unity gives us on this most of the time is exactly what you want. Having that mono behavior piece is really important so that we can add this component to a game object in the inspector. If we remove that, we will not be able to add our script to a game object. It's also very, very important that count up matches our file name. So the file name of count up, even the case is important, should be the same text as our file name exactly. If you maybe renamed the file or something like that, these can get out of sync. The easiest way to fix that is just delete your file and create a new one. The curly brackets, the way you can think about them is signifying ownership of the code inside. So we have curly brackets that come after the count up. That's on line 6 here. And the closing bracket is on line 18. Everything in between those we're saying belongs to the count up class. Inside of here, at the count up class level, we can define functions. I may call them methods, method, function, exact same thing. I don't know why there's two words for it, but there are. So function, method, both of those are the same thing. That's what we already have defined here with this void start and then the little parentheses, and void update with the parentheses. And then those also have curly brackets that come next. So what that's saying is there's a function called start. The void means that it doesn't return anything, and we'll get into what returning does in a future video. And then Unity says you can put some code here into the start function. I'm saying you can put it into because we're going to put it inside those curly brackets. These two functions are what I'm going to call magic Unity functions. Unity will call these automatically for you at some point in the game's lifecycle. In a future video, I'll go over that component lifecycle, but the important thing, they already told us here, that start is called before the first frame and update is called once per frame, which is perfect. In most game engines, probably all game engines work the same way. They will render or display one at a time a bunch of images, and over time, something small will happen. There'll be incremental changes in between each of these pictures, and that's how we get the smooth look. That's where the 60 frames per second you may have heard of comes from. If we're talking about 60 frames per second, that means 60 individual still images are shown on the screen every second. In this code case, you'll see that update is called once per frame. So that means this function would be called 60 times in 1 second. We're going to use that information in this video specifically to get that counting up. Before I get too deep into the functions, let's define what I'm going to call class member variables. That may sound a little bit scary, but we're going to walk through it really slow. And we actually need 2 of these for the example we're going to do today. We're going to define these 2 and then we're going to walk through what's happening, okay? We're going to go private TextMesh Pro, UGUI, and we're going to call it text. And we have to put a semicolon at the end. We're also going to define a private float speed, and we're going to do equals 1 and then put a semicolon. So what's happening here? We've defined two class member variables. So remember, our count up is a class. That's why we're calling it a class member. We're in the count up class right now. We're in between the open and the closed curly brackets for our count up class. They are defined at the class level. They're not inside of a function. They're only defined in the class, which means we can use them later in functions, and we're going to. We're defining two variables, text and speed, and variables, much like the name sounds like, are pieces of data that we will most likely change their value over time. So their value may vary, variable, over time. A variable has to have a type in C#. In most programming languages, they have to have a type. In C#, there are a bunch of types, and you can even see here that we have TextMeshProUGI is a little bit different than the float, right? It's this green color and the float is blue. TextMeshProUGI also starts with a capital letter, much like our count up, which tells us that TextMeshProUGI is a class or a struct. That means it may also have class member variables and functions. Since I've used this TextMeshProUGI many times before, I can tell you it does have class member variables and functions that we're going to use in this video. Float, on the other hand, is what we call a primitive type. It's not going to have class member variables or generally functions on it because it is a primitive type. And what primitive types do is just store some value. In this particular case, we want to store a number that can have a decimal in it. So I'm going to use float. You can think of primitive types as just data storage and classes as more complex combinations of primitive types and functions. Now, there are some primitive type functions, but they're pretty few and far between. So float is a number, but there's not just like a number type. We have to be very specific about what kind of number we want to be. For the most part, float is the value you want when you're dealing with decimal numbers. If you want it to be a whole number, it's called an integer or int. In this case, the speed is going to be used to adjust how quickly we're going to count up. But if we can only go from 0, 1, 2, 3, 4, that's like a really big step up, right? That's why we're using a float here. So we can have like 0.25 speed. So 25% speed or 50% speed. So we can go up at a much more granular speed. We can kind of ramp it up or ramp it down. The other really important type for us to talk about here is string. A string type is a text type. So if you want some kind of text, like if you want something to say hello, or by default, the TextMesh Pro component says new text. That new text piece of text is a string that is stored in a variable. We're going to override that to be some number instead, but to display text, it needs to be a string. So that's why it's important to know that this is also a type that we're going to use in this video. Variables have types. They also have a name. In this case, the TextMesh Pro one we called text, and the float one we called speed. There's a convention that I follow just to make it a little bit more clear to me what kind of variables I'm using at a particular moment, where the class member variables I will define starting with an uppercase, and the variables I define inside a function I will use lowercase. That's a convention you can choose to use as well to keep it more straight in your head about where is this value coming from. There's one other thing as part of our definition of this variable though, and that is they both are called private. You may think about how we have the class defined as public, and these are now private. You're catching on to something there, that these are called access modifiers. Every class member variable, every class, and every function has an access modifier. There are 4 key access modifiers that I use. There are a couple more, but I've never used them, so I don't know how valuable those are. But there's only 2 we need to care about in this video: public and private. Public, as you may have guessed, is open to the world. Everybody can see what's public. And then there's private, which you hope nobody can see. And C# will enforce that nobody else can see them. Only in the scope of this class can you see these private variables or private functions. Generally speaking, we want to keep all of our variables and all of our functions at the most restricted access level possible. This helps us reduce bugs by not letting just anybody change values of variables from anywhere. You end up with a really bad code design when you go that way. So that's why the private should be the default access level that you set any variable or function to, unless you really know why it should be more accessible than that. So for the scope of this one, we want them to be private, because only this class will modify these values. In a future video, we'll get into what are some of these other access modifiers and what are those useful for, but not to muddy the waters of this video, that's the key things you need to know. I'm going to do one more thing to these two variables. Since these are class member variables and they're private, there's no way for me to modify them, right? But in Unity, I will probably want to modify, for example, the speed in the inspector. How can I do this? I'm going to add a square bracket, serialize field, close square bracket, to both the TextMeshPro text and the float speed variables. This is what C# calls an attribute, and this one specifically comes from Unity that allows them to show private variables in the inspector. This allows us to keep our code clean, keeping them private, while still being able to modify them in the inspector. That's a really cool trick that Unity has. We're going to do one more variable definition here. I'm going to make a private because it's a class member variable, and I don't want anybody else to modify this besides this class. We're going to be a float because it's going to be a decimal number. I'm going to call it time display, because this is going to be the value that we're going to display on the TextMeshPro text. And I'm going to assign it a value with equals 0 and then semicolon. We're going to use that in the update function. We need it to be defined at the class member variable level because we want it to stay there outside of the scope of the function. In a function, we can define time display, but it will be reset to whatever we assign it to at the beginning every time the function is called. So if we want a number to count up, it doesn't make a lot of sense for it to get assigned at the beginning of that function every time because it will always be set to that default value. Defining at this class level allows us to have it defined to one value and then persist between calls to update. We're going to go inside that update function and we're going to write our first, let's call it logic lines of code. So far we've only done variable definitions, but now we want to actually modify those values of those variables over time. We're going to introduce a new concept here called the if statement. This is one of the most common statements in all of programming. It allows us to check if a value is true. We do that by typing if and then doing parentheses and then what we would like to check. What I'd like to check here is that the speed is greater than 0. So remember, speed is a float value. It could be any number, negative, positive, decimal, anything like that. But since this script is called count up, if speed is negative, it would actually be counting down. So I want count up to only count up. So that means the speed has to be greater than 0. That means any value that is positive. So we're going to do that. And for if statements, they act very much like what we saw here on the function, where we want to put these curly brackets because we want to put code inside of the if statement. That means only if speed is greater than 0 do we want to execute this code. If the speed is less than 0, we don't want to do anything at all. Inside of here, then we want to do something, right? What we want to do is update our time display because it's going to be the value we're going to display and we're going to change that over time. That's going to give us a cool counting up animation on the text. What I'm going to do is time display and then I want to change this value, right? So that means I'm going to do equals because I want to assign a value to the time display. And I'm going to put time display again because I want it to equal the value it's currently at plus some other value. So we're going to do time display equals time display, and we're going to add something. So we'll do plus. And here we're going to use time with a capital T dot delta time. Time with a capital T comes from Unity Engine that gives you information about time stuff. The important thing here, and what is the most common thing to get from this time class, is the delta time. The delta time is the amount of time that's passed since the last frame was rendered. So remember that in game engines, we show a frame, we show a frame, we show a frame. What this delta time captures is the time since the last frame was displayed. That's a really helpful thing because update is called once per frame, right? This allows us to say, since the last time this function was called, this amount of time has elapsed. So we're going to increment our time display just by however much time has elapsed. So if we're getting, 30 frames per second, this value will be 0.0333333333. If we're getting 60 frames per second, it'll be 0.016666666667, right? All we're doing is adding whatever the value of time display is plus this number, which will be a very small number. Since we're going to update this value hopefully 60 times in a second, maybe more, that'll give us like a counting up effect like you see all the time. But remember that we have this speed that I told you we were going to use to modify how quickly we would count up what we'll do then is do time display plus time.deltaTime times speed. That'll allow us to control from the time display perspective at least how fast we're going to count up. If we set this to 0 though, remember it's not going to change at all. If we set it to anything greater than 0, we're going to take that really small number from time.deltaTime and multiply it by this number. So if we set it to be a number below 1, that's going to make it go really slowly, but still counting up. If we set it to be like 100, then it's going to count up very, very quickly, because if we're getting 60 frames in a second, it's going to go 100 times faster than that. It'd be like getting 600 frames a second. C# also respects your favorite acronym from, 5th grade, early math, PEMDAS. Maybe you heard, please excuse my dear Aunt Sally, something like that. That means that time.deltaTime times speed will happen first, because that's multiplication, right? Parentheses, exponent, multiplication. So multiplication happens, and then we do the addition. And that's exactly what we want. We want the time.deltaTime times speed to happen, and then add that into the time display. We only need one more line of code to actually make this do what we want it to do. So we've really only written one line of code and one if statement so far, right? Everything else has been just variable definition. What we're going to do is actually display this time display now on the TextMeshPro. So we're going to do text dot, and let's talk about the dot before we go any further. So on time.deltaTime, we did time, which is the class name, right? Like in our case, it would be count up dot. That dot tells the computer, I want to access a class member variable or a function on that class from the class time. In this case, delta time is a class member variable that is public on the time class. That's all that the dot is doing. It's saying, computer, for this class, or for this variable, whatever it is, I would like to access some of the class member variables or a function on that class. In this case, we want to update the text of the TextMeshPro. So we're going to say text dot saying, hey computer, please tell me what can I do on the TextMeshProUGui component. And it will tell us set text is something we can do that will change the text of this TextMeshPro component. Since set text is a function, we want to call a function. That's what it's called when we're going to execute a function. So update is called once per frame by Unity. We are now going to call, that means execute, the set text function on the TextMeshProUGui component, however many frames per second we're getting. So to do that, we do these parentheses, and inside of those parentheses, we need to say, what do we want the text to be? Because set text is asking for one variable to be passed in. Whenever we're passing something into a function, we call this either an argument or a parameter. I don't know why it's an argument to send something to a function, but that's what it's sometimes called. You'll also hear them called parameters. So in this case, it's taking one parameter or argument. The problem though is time display is a float. So if we just put time display, it's going to complain at us. You'll see this red underline. And if we mouse over that, it'll say
CS1503 argument 1 cannot convert from float to string.
Which is good because it's actually telling us what the problem is. It's telling us that set text expects there to be a string, but we're giving it a float. So how do we fix that? Luckily for us, C# provides on floats a way to convert from a float to a string. Because remember, a float's just the number. It's not text, it's a number. Text has to have quotes around it. So what we're going to do is say time display dot, because we want to access something that is on a float. And you'll see that there's the ability here to do toString. That's exactly what we want. What this does is converts whatever type we have to a string. In this case, a float to a string. And then a pair of parentheses, because this is a function, we need to call it. So what that's doing is calling the toString function on the time display float. And that will then return a string to the set text function from the TextMeshProUGui component. The problem with this code though is the text as output isn't very readable. This is primarily because the text doesn't always have the same size. Let's say that it's 0.123. On the next frame, maybe it's 0.135763. If that's the case, then we're going to have some jitter as the number changes because we're showing the least number of significant digits in that float. So what we need to do is actually format this string so it will have a consistent number of decimal places. If you think back to some of the early math classes, that's something we did by it would either round or truncate off after a certain number of digits. Your math teacher maybe told you, only give me 4 digits. We want to do the exact same thing here with this string. We want to tell the computer only display a certain number of digits after the decimal, because after that we don't really care anymore. To do that, we're going to use a numeric format specifier on this toString. What that means is the toString function here accepts a string that will tell it how it should format the string. I'm going to pull up the Microsoft documentation on how this works. If we pass to the toString a string that says n and then the number of digits we want to display, it will automatically format our float value to be something like, from this documentation, 1234.567 if we used n3. In my case, I'm going to choose n2 because I think 2 is a good number of numbers after the decimal to show when we're talking about time. Since the toString function wants a string as well, we need to pass a string value. You define a string value with quotes. We're telling it, please use this exact text that's in between these quotes. So in this case, we're going to use the capital N and 2 because that's what Microsoft tells us we need to do to make this do what we want. This is what I was talking about earlier, that the documentation both Microsoft and Unity have are really essential resources when you're working through your programming journey. And of course, I have some links to everything that we've talked about in the description. If we open up the Unity editor and I select the TextMP GameObject that has my TextMeshPro text on it, I will click Add Component and we'll see that my new script CountUp is accessible if I start typing count up. If I select that, just like any other component, it'll show up on my list of components on my GameObject. We'll see that we don't have that text reference, so I'll drag the TextMeshPro to that text reference, and I'll click play. Once it starts, we'll see that the numbers immediately start counting up, where we only have those 2 decimal places because of that n2 that we passed to the toString. And we can, of course, adjust the speed just like we would normally see in the inspector. Anytime that we have normal numbers, we have this kind of number input field. If we increase the speed, it goes faster. If we lower it, it goes slower. If we set it to a negative number or 0, it will stop updating. With that, we've made our very first script ever that will allow us to make some text count up over time, and it shows a pretty cool animation where the numbers kind of flicker as it's counting up. Hopefully that was really clear each step of the way exactly why we were doing each thing that we were doing. It's totally okay if you had to pause, rewatch stuff, reread the documentation. All that's totally normal as you're starting to learn how to write code. Even today, I've been writing code for almost 20 years now, and still I will review documentation. I'll have to look up stuff. You don't need to feel ashamed if you need to go to Google and ask Google, how do I do something? I do that to this day, and I don't think there's anybody that just knows how to do every single thing that they want to do. The most important thing that I hope you took away from this video is not how to write a class, how to serialize private variables, write an if statement, or make text count up. What I hope you got from this video was actually that there are resources available to you to help you do whatever it is you're trying to do, especially at like the basic level whenever we're just getting started writing code. Most of the time, Unity and Microsoft have documentation supporting you doing whatever it is that you want to do. They might not have specifically, here's how you make text count up, but they will have something saying, hey, here's how you update the text of a TextMeshPro text. Here's how you can format that number. And you can put those 2 pieces of data together running in the update loop, and that's how we have it count up. So what I mean to say by that is reading documentation, while maybe not like the sexy topic to do, is very important, and it's very important to be able to do that efficiently so you can get the outcome you're looking for. When a programming language or a game engine has really good documentation, that makes it significantly easier to achieve an outcome, because then you can just understand, what do they allow me to do? What is the interfaces I have to work with? That's like the TextMeshPro has a set text function that's part of the TextMeshPro interface. What options do I have available? What functions can I call? And when you understand that, you can put together your existing knowledge plus this new knowledge you got from the documentation to achieve some new result that you're trying to get. There might not always be a tutorial about exactly what you want to do, so there's a little bit of problem solving involved here to think about what is it you're trying to do, take the knowledge you have, take the documentation, put those 2 things together to achieve that result. If you can master that, and it will take some time, then you'll be a coding expert. I almost forgot to assign you the homework assignment. The first link in the description is going to be the homework link. It's going to take you to the random documentation from Unity. I want you to make a new script using that to show me a random number every frame, rounded to 3 decimal places. You've learned everything you need so far to get that done. You just need to read a little bit about the random documentation to see how to get a random number. Drop a comment down below with your completed assignment and a link to a video showing your code and the random number displaying on some TextMesh Pro text. No cheating. I know for sure there's a video about this out there. Do it on your own. That's how you're going to learn. If you got value out of this video, please consider liking and subscribing to help the channel grow, reach more people, and add value to more people. This new video is posted every Tutorial Tuesday, and I'll see you next week.